Hello, very good evening, guys. Welcome to Resultant, the faculty-driven platform for your GATE and ESC and also SSC preparation. So I welcome you all to this live session, and today is very important because today we'll be talking about the practice session of the highest weightage subject for SSC, that is fluid mechanics. So good evening, let me check from my end. Let me check. Okay, very good evening, all of you. Okay, all right. चलिए, all good. चलिए, good evening, very good evening. So आज हम लोग 30 questions, the most repeated PYQ from the fluid mechanics subject will be discussing. SSC and RRB JEE दोनों के लिए it will be helping you out. Okay, so let's begin and let's practice the top 30 questions. Okay, good evening. चलिए, very good evening. All right. Second, let me check. I think it's all good. Perfect. So fluid mechanics, almost like we can say 30 to 40% of the question is usually being asked from this subject. ठीक है, SSC JEE में specifically 30 to 40% यहीं से पूछते हैं, तो you have to have a complete understanding, right? तो FM का complete detailed PYQ, most repeated PYQ questions will be discussed in this. So good evening, all good. Thank you, Negi. So all of you, those are not yet, just subscribe to this Resultant channel. जल्दी से subscribe कर लीजिए because you will be getting the latest update about all the examination for GATE, ESC, SSC, JEE for mechanical and civil. Okay, good morning विजॉय, गुड इवनिंग स्पेसिफिकली. लाइक कर दीजिए, सब्सक्राइब कर दीजिए, शेयर तो आपने अब तक कर दिया होगा. तो कैन वी स्टार्ट? यस, शैल वी बिगिन विद द क्वेश्चंस? And if you have any doubt and difficulty, you can do contact me on this mail ID, that is suraj@resultant.in, or you can connect with me on my Telegram channel. Good evening. It's like, we can say it's a huge difference, right? A GATE is basically for we can say bachelors having the we can say BTech or bachelor's degree, or if you're having a diploma degree, then you can get into the JEE. But bachelor's के साथ भी you can directly apply for JEE examination. Actually, the vacancies from in the JEE is slightly higher. ठीक है, GATE में you can get through the PSU examination. Okay, Raju. Fine. So can we start with the first question? Please do let me know in the comment section with the like button. जल्दी से बताइए. All good. Can we start with the first question? And this is the highest weighted subject. I'm again repeating, if you're planning to give SSC JEE, you have to attend this today's session. Okay. चलिए, first question on the screen is this one. And these are the most repeated. You will be frequently seeing these kind of question. I've made sure that some question from the fluid machinery is also being added. Okay, Bijoy, Negi, Raju. First question on the screen is, which of the following is an imaginary fluid? Which of the following is an imaginary fluid? Okay, option A, non-Newtonian, ideal fluid, Newtonian fluid, or real fluid. Quick answers, बहुत जल्दी you have to give me the response because this is very easy. A, B, C, or D. Which of the following is an example of an imaginary fluid which is not existing in real life? Obviously, we will be calling it as ideal fluid because ideal fluid are, we can say, incompressible fluid which is not possible in real nature. Okay? B, very good, Raju. Option B is a correct answer. Okay? What is the property of an ideal fluid? Is an incompressible fluid and imaginary. Okay? Very good. Next question. Dash is not a property of a fluid. Along this 4 option, which of the following is not the property of the fluid? Mass density, area, specific volume, or specific weight? Which is not the property of the fluid? Mass density, area, specific volume, or specific weight? Very easy. Again, I think option B is a correct answer. Area is not a property of the fluid. All these, mass density, specific volume, specific weight, these are the property of the fluid. ठीक है? Fine. Clear है? Done. And this was asked in, I think, 2018 or 19. 18 or 19 this question was asked. Next question. Make sure that the recent year questions is I've taken up in this 30 problems. Okay, the fluid density of a fluid to the weight density of the standard fluid is called. What is the ratio of fluid density of the fluid to the fluid density of the standard fluid called? Mass density, specific weight, specific gravity, or specific volume? A, B, C, or D? Quick response. Let us try to complete today's session in 40 minutes. 30 question, 40 minutes, more than sufficient. Yes. Mass density, specific weight, specific gravity, or specific volume? A, B, C, or D? The correct answer for this, the row of fluid to the row of standard fluid, normally we call it as the water. So what is this ratio called? This ratio is nothing but the specific gravity. Option C is the correct answer. Very good. Option C is the correct answer. Chaliye. Next question. Kinematic viscosity is the ratio of yes, kinematic viscosity is the ratio of, okay, as compared to GE, EAC top exam regarding the post and power. Yes, definitely EAC for technical examination, engineering service is having the top difficulty level, or because the top highest, because the most prestigious post that you can get from EAC. Okay, but the thing is, if you are giving JE also, from there also you can get into that level, but it takes some time. At least 7 to 8 years का gap आ जाता है. If the gap is there, if you are going through JE level, or if you are going through your EAC level, that directly you will be getting we can say a top post, okay, which will be having power and money. Definitely money will be slightly less, power will be there, but if you want to go above that, we'll be having a UPSC IAS paper, right? But that is a different league, that is not a technical portion, that is more sort of a non-technical. Kinematic viscosity is a ratio of absolute viscosity to the mass of the liquid to the absolute viscosity to the density of the liquid, and density of the liquid to the absolute viscosity. Central, Raju, EAC will be in the central post, okay. Through central, you will be having different state allocation. A, B, C, or D? Yes. Yes, Raju. Kinematic viscosity is equal to dynamic viscosity by the density of the fluid or liquid. That is option C is the correct answer. Okay. Option C, absolute viscosity to the density of the liquid. Option C is the correct answer. Clear? No, B is not the correct answer. B is not the correct answer. Okay. Done. Bijoy, Negi, is this clear? Fine, option C, perfect. Next question on the screen. In a Newtonian fluid, the shear stress is directly proportional to the rate of shear strain, inversely proportional to the rate of shear strain, balances pressure, balances inertia stress. A, B, C, or D? Okay, quickly. Option A, option B, option C, or option D? Which of the following is the correct statement for Newtonian fluid? A, Jaydev is going with option, obviously यार A. Newtonian fluid है, direct proportional होता है, that is du by dy, है ना, directly proportional straight line curve, है ना. Option A is the correct answer. Very good, Jaydev. Next, a tank is containing water up to a height of 2 meters. Calculate the pressure at the bottom of the tank. What is the pressure at the bottom of the tank if the level of water is 2 meters? Easy question. Quickly. This is, I think, question number 6. Yes. This is specifically, I'm running this series for SSC JE this year's examination 2024. ठीक है, this year's paper के लिए I am running this. Yes, for some questions there will be database problem. ठीक है, specifically power plant में. In power plant engineering there will be some questions that will be database, so you have to solve this question. Tomorrow we'll be talking about the thermal and its application. ठीक है, fine. चलिए, व्हाट इज द फॉर्मूला फॉर प्रेशर इज इक्वल टू रो जी एच, वाटर है ना, सो 1000 into 9.81, height is 2. What is the answer that you are getting? A, B, C or D? Option A, option B, option C or option D? जल्दी से quickly. 196 to 19620. Option D is the correct answer, है ना? 19620 Newton per meter square. Option D is the correct answer. ठीक है, 19,600. This is all PYQs. These are all previous year questions of SSC JEE. ठीक है, रो जी एस सिंपल डायरेक्ट स्ट्रेट अवे क्वेश्चंस. डन. नेगी, देव, यस, विजय. चलिए नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 7 ऑन द स्क्रीन. Piezometers are used to measure. Piezometers are used to measure viscosity of the fluid, velocity of the fluid, gauge pressure और temperature. चलिए A, B, C और D. Piezometers are used to measure which parameter or which physical parameter? A, B, C or D. Viscosity of the fluid, velocity of the fluid, gauge pressure or temperature. Obviously you might have seen the piezometer, है ना, आपने देखा होगा. It is usually we are using to measure the pressure of gauge pressure of the fluid, है ना. To measure the gauge pressure we are using the piezometers. Option C is the correct answer. Very good. Next, the resultant upward pressure of the fluid on an immersed body is called. The resultant upward pressure of a fluid on an immersed body. Very easy question. इसको क्या बोलते हैं? What is an upward thrust or upward force or pressure that is applied of the fluid on an immersed body? If you are immersing a body inside the fluid, एक upward force लगता है. What do we call that? That is nothing but the buoyancy force or buoyant force. ठीक है? Option B, buoyancy or buoyant force is the correct answer. We can call it as buoyant force also. इसको हम buoyant force भी बोलते हैं. Very good, very good. Next question. This was question number 8. Question number 9 on the screen. Important question. This type of question 3 times this is being repeated in the SSC JEE. 3 times. I've counted 2012 में, 18 में and I think 2020 में भी I think. ठीक है. 3 times this question was repeated. A floating body is said to be in a state of stable equilibrium when you will be having a stable system. When its metacentric height is 0, when the metacenter is above the CG or center of gravity, when the metacenter is below CG, only when its center of gravity is below its center of buoyancy. A, B, C or D. देखो स्टेबल सिस्टम के लिए याद रखिएगा, स्टेबल सिस्टम के लिए, for stable system your metacenter must be or always be above the center of gravity. When the metacenter is above center of gravity, then you will be having a restoring moment which will be trying to stabilize the system. Option B is the correct answer. Very good. 9th का B question. B answer है. चलिए 10th question on the screen. When a liquid rotates at a constant angular velocity about a vertical axis as a rigid body, the pressure increases linearly as its distance, radial distance, varies inversely as the altitude along any vertical line, varies as the square of the radial distance, decreases as the square of the radial distance. A, B, C or D? A, B, C or D? Quickly. A, B, C or D? If you are able to calculate the pressure head, है ना, pressure head निकल जाएगा तो from there you will be able to answer to this question. Quickly, Jaidev, Negi, Raju, Bijoy, quickly, everyone. A, B, C or D? देखो, we know that R is equal to V square by 2G or R square omega square by 2G, है ना? This is the pressure head and P is equal to rho G H. So we can simply say it varies the square of the radial distance. Square of the radial distance. Option C is the correct answer, है ना? P is equal to rho GH. प्रेशर हेड निकाल दिया हमने. प्रेशर हेड इट इज डायरेक्टली प्रोपोर्शनल टू द स्क्वायर ऑफ द रेडियल डिस्टेंस. सो हाउ द रेडियल डिस्टेंस इज वेरिंग, द प्रेशर हेड विल बी वेरिंग, और ऑब्वियसली उसी रेशियो में आपका प्रेशर भी will be changing. So option C, varies as the square of the radial distance, is the correct answer. Clear hai? Perfect. Very good. 11th question on the screen. In a uniform flow, the velocity of the fluid particles. यूनिफॉर्म फ्लो बहुत आपको इंफॉर्मेशन मिल चुका है. बाय रीडिंग दिस वर्ड यूनिफॉर्म फ्लो यू आर एबल टू अंडरस्टैंड सम वेरी इंपॉर्टेंट अंडरस्टैंडिंग. द वेलोसिटीज ऑफ द फ्लूइड पार्टिकल्स मूव इन अ वेल डिफाइंड पाथ, डू नॉट चेंज विद रिस्पेक्ट टू स्पेस एट अ गिवन टाइम, आर ऑलवेज डिपेंडेंट ऑन टाइम, आर परपेंडिकुलर टू ईच अदर. यूनिफॉर्म फ्लो बताइए ए बी सी और डी क्विकली. यूनिफॉर्म स्टेडी फ्लो की बात नहीं कर रहे, वी आर टॉकिंग अबाउट यूनिफॉर्म फ्लो. यूनिफॉर्म फ्लो मींस इट इज नॉट चेंजिंग विद रिस्पेक्ट टू स्पेस एट अ पर्टिकुलर इंस्टेंट ऑफ टाइम. ऑप्शन बी इज द करेक्ट आंसर. ऑप्शन ए इज टेलिंग अस अबाउट स्ट्रीमलाइन फ्लो. वेल डिफाइंड पाथ मतलब वी आर टॉकिंग अबाउट स्ट्रीमलाइन फ्लो. डिपेंडेंट ऑन टाइम दैट इज अ ट्रांजिएंट फ्लो और अनस्टेडी फ्लो. क्लियर है? ऑप्शन बी इज द करेक्ट आंसर. ओके चलिए नेक्स्ट क्वेश्चन नंबर 12. Next question quickly, very easy. If the stream function is equal to 3x square minus y cube for two-dimensional flow, what is the velocity component in x direction at point 1, 3? आपको निकालना है the velocity in the x direction at 1, 3. Quickly, A, B, C or D. Simple question. Option A, option B, option C or option D. Stream function is being given. I hope so you remember the formula quickly. और सबसे अच्छी बात क्या है, all the options are having different magnitude. तो even if you are committing a mistake with a negative sign, कोई problem नहीं है. How stream function and the velocity component in x direction are related with each other? Quickly. A, B, C or D. देखो phi is equal to xi is equal to 3x square minus y cube. So obviously we can say velocity is equal to minus d xi by dy, है ना? That too differential element. So that is equal to minus minus plus, that is 3y square. So we want to calculate at 1, 3. Velocity will be equal to 3 into 3 square, that is 27 meter per second. Option C is the correct answer. Option C, 27 meter per second is the final correct answer. ठीक है? Right? Done? Clear? Any doubt if you're having? Directly they are asking about the velocity component in the x direction. So obviously you know the formulation. ये वाला formulation लगा के you're good. Very good. Next 13th question on the screen. According to Bernoulli's equation, which of the following is representing the correct statement or correct equation? Option देखते ही mark कीजिए और आंसर बताइए. The most, I think this is the most easiest question of today's session. 2015 का है या 12 का है, I think 12 और 15 का question है. Which of the following is telling us about the Bernoulli's equation? Obviously option A is the correct answer. ठीक है, ऑप्शन ए स्पेसिफिक ग्रेविटी दे रखा आपको P by rho g, V square by 2g and Z is the pressure head. ठीक है, so we are getting option A is the correct. Very good, very good, perfect. Next 14th question. Pitot tube is used for the measurement of pressure, flow, velocity or discharge. ये थोड़ा सा ध्यान दीजिएगा because what happens sometimes you are having a confusion and we are landing with the wrong answer. Pitot tube specifically we are using to calculate which of the parameter? 14th question. Pressure, flow, velocity or discharge. Option quickly. C. Very good Bijoy. Option C is the correct answer. Velocity. Option C is the correct. Very good. बहुत बढ़िया. Perfect. Option C. Pitot tube. I hope so you might have seen. ऐसे करके होता है. Something like this. You are calculating. You are using this kind of device to calculate the velocity. चलिए. Next, venturi meter is used to measure the flow of fluids in pipe when the pipe is horizontal, vertical flowing downwards, vertical flowing upwards or in any position. Venturi meter हम लोग use करते हैं to calculate the flow rate. So tell me what should be the alignment of the pipe, horizontal, vertical, flow downwards, vertical flow upwards or any position, A, B, C or D. Quickly. Yes. Good evening, good evening. A, B, C or D, quickly. Venturi meter, Baba, you can use the flow rate at any inclination, at any position. Very good. कोई भी orientation में won't be having an issue. If you are using venturi meter, you can calculate the flow rate. Horizontal हो, vertical हो, it is not having any issue. ठीक है? At any position we can go with the measurement of the flow rate. ठीक है? चलिए, very good, Sai Kumar. Next, 16th question on the screen. A pipe of diameter 10 centimeter carrying water at 5 meter per second reduces into a smaller diameter having a diameter of 5 centimeter. What's the velocity in the smaller diameter? Very easy question. What you have to use? Which equation you have to use? Quickly. Good evening, good evening. Which equation you have to use? A continuity equation. है ना? Continuity equation. चलिए, apply continuity equation. Get tell me the answer. A1 V1 is equal to A2 V2. है ना? We can use a continuity equation. A1 V1 is equal to A2 V2. The conservation of mass. Yes. We are having a pipe, so pi by 4 d1 square into v1 is equal to pi by 4 d2 square into v2, है ना? तो यहाँ पे लिख देते हैं d1 square, d1 is 10 square into v1 is 5 is equal to d2 is 5 square into v2. यहाँ से calculate the value of v2. What is the value you are getting? Tell me the correct answer. And B 20. Yes, B 20. 20 meter per second is the correct answer. 20 meter per second is the correct answer. 20 लॉक कर दें, बहुत बढ़िया. 20 is correct. 20 meter per second. Next question, 17th question on the screen. आज लगता है 40 minutes we will be able to cover the 30 questions. The discharge of a liquid of kinematic viscosity is 4 into 10 power minus 2 meter square per second. आपको kinematic viscosity is being given minus 2 meter square per second. And through 80 mm diameter pipe, diameter दे रखा है 80 mm, ठीक है, is this much, ठीक है. आपको discharge दे रखा है. Discharge is being given as 3200 pi into 10 to the power minus 4 meter cube per second. इसको भी कर लेते हैं 80 into 10 to the power minus 3 meter. चलिए, tell me the answer. Is it a laminar, turbulent, transition or critical? Critical करके कुछ होता नहीं है. We have to go with either A or B. Either A or B. Quickly. Question number 17 on the screen. Easy question है, not a difficult one. Discharge is being given, है ना? Discharge, what is the formulation for discharge? Discharge equal to area into velocity. Discharge क्या होता है? That is equal to area into velocity. ठीक है? Discharge given 3200 pi into 10 to the power minus 4. Area is pi by 4. Diameter square 80 into 10 to the power minus 3 whole square into V. Pi से pi cancel, right? So we can solve it and tell me the value of V. Quickly, solve it and tell me the value of V. V निकलने से calculate the value of Reynolds number. V निकलने से calculate the Reynolds number and tell me the final correct answer. Yes. कितना आ रहा है? It will be 3200 into 10 to the power minus 4 into 4 divided by we can write this as to be 80 into 80 into 10 to the power 6. So what is the value? Velocity is I think 200 आ रहा है. Please check quickly. 200 मीटर पर सेकेंड. वेलोसिटी कैलकुलेट करने के बाद डायरेक्टली वी कैन यूज अ रेनॉल्ड्स नंबर फॉर्मुलेशन. टेल मी व्हाट इज द टाइप ऑफ फ्लो. 3200. अरे so RE is equal to V into diameter by mu. So 200 into 80 into 10 to the power minus 3. Kinematic viscosity is 4 into 10 to the power minus 2. That is simply what you are getting. So this will be coming top. ये एक zero cancel out हो जाएगा. 2 minus 1. So 200 into 8 by 4. That is 400. है ना? And that is a laminar flow. That is a laminar flow because Reynolds number is less than 2300. ठीक है? It's a laminar flow. Option A is a correct answer. Done? It's a laminar flow. We are getting option A as a correct answer. Clear है? Everyone? Done? Simple है भाई. That is flow through pipe. It's a flow through pipe formulation. So we know that if the Reynolds number is less than 2300, it's a laminar flow, and we are getting only 400. Perfect. ठीक है? Laminar flow. Okay. Question number 18th on the screen. 18th on the screen. Water at 20 degrees Celsius is flowing through a 20 centimeter diameter pipe. Take kinematic viscosity at 20 Celsius as 0.0101 stoke. ठीक है? Assume that the changes from laminar to turbulent at Reynolds number 2320. What will be the velocity? What will be the velocity? Quickly. Simple formulation. Reynolds number is given. Kinematic viscosity is given in stokes. है ना? अच्छा, how much is 1 stokes in centimeter square per second? 1 stokes is equal to how much centimeter square per second? 0.1, 0.01 or 1 or 10 or 100. कितना होता है? क्योंकि आंसर इज गिवन इन सेंटीमीटर. इट्स इक्वल टू 1 ओनली, है ना? बस कुछ चेंज करने की जरूरत नहीं है. रेनॉल्ड्स नंबर इज इक्वल टू वेलोसिटी इनटू डायमीटर बाय काइनेमेटिक विस्कोसिटी. चलिए, वेलोसिटी यू हैव टू कैलकुलेट. रेनॉल्ड्स नंबर इज गिवन एज 2320. वेलोसिटी वी नीड टू कैलकुलेट. डायमीटर इज गिवन एज 220 and this is 0.0101. चलिए, 0101 1 by 10, sorry, 0.1. Yes, 0.1. हाँ, perfect. हाँ, perfect. तो ये कितना होगा? 0.101. एक डेसिमल will be shifted. 1 decimal will be shifted, I think. अब ठीक है. 0.1. Quickly. What is the answer? A, B, C or D? A, B, C or D? B. Yes. A, B, C or D? Quickly. A, everyone is getting A. A. 1.117. Yes. A लॉक कर दे. वेरी गुड. 1.117 सेंटीमीटर पर सेकंड का करेक्ट आंसर. परफेक्ट, वेरी गुड, बहुत बढ़िया. नेक्स्ट 19th क्वेश्चन. यस, चलिए. यूलर्स नंबर. नाउ डायमेंशनलेस नंबर वाले क्वेश्चंस आ गए. रिमेंबर वन थिंग, डायमेंशन नंबर से एवरी ईयर दे आर आस्किंग एटलीस्ट 1 क्वेश्चन. तो जितने डायमेंशनल नंबर्स आर देयर, एटलीस्ट गो थ्रू दैट. इट विल बी हेल्पिंग यू इन द मेन एग्जामिनेशन. ठीक है. यूलर्स नंबर रिलेट्स टू इनर्शिया एंड इलास्टिक, इनर्शिया एंड ग्रेविटी, इनर्शिया फोर्स एंड प्रेशर फोर्स एंड विस्कस फोर्स. A, B, C or D. Euler's number is telling us about the ratio of what. क्या लॉक करें? Which option do we need to lock? जल्दी से. Which option do we need to lock? Inertia by elastic, inertia by gravity, inertia by pressure or pressure by viscous? A, B, C or D? अरे भाई, yes. Root of inertia by pressure force. So we are getting option C is the correct answer. C, very good, Sai. C is the correct answer. Inertia by pressure force. Inertia by pressure force. Is this clear? Root of inertia by pressure force is the Euler's number. ठीक है? All right, clear, done. Next question. C, very good, very good. C is the correct answer. Next 20th question. For hydrodynamically smooth boundaries, the friction factor for turbulent flow, याद रखिएगा, they are asking about turbulent flow. Friction factor small f depends on relative roughness only. It's a constant value, depends only on Reynolds number. It's a function of Reynolds and the relative roughness. चलिए quickly. Exactly, very good. Option D was your fraud number. चलिए quickly. A, B, C or D. Friction factor याद है कुछ? There's a formulation to calculate the friction factor. Somewhere 0.316 divided by Reynolds number to the power 1/4. यही है? Friction factor is equal to 0.316 for turbulent flow divided by Reynolds to the power 1/4, है ना? अब बताइए आंसर. D, everyone is going with option D. Turbulent flow, Mr. X, not laminar. Turbulent की बात चल रही है. They are talking about turbulent flow. So remember some empirical formulation जो होते हैं ना, उसको याद रखिएगा. Okay. हाँ, very good, very good. Reynolds and roughness. अच्छा, tell me, in this formulation, do we have any roughness parameter? मतलब, I'm curious to ask you. इस formulation में, this is friction factor ना, this is your friction factor. इस formulation में we only are having the Reynolds number. तो हमारा आंसर C नहीं होना चाहिए. Do we? I'm just asking you. Do we need to have option C as the correct answer? देखो, A और B नहीं हो सकता. Now we have to consider between C and D. Friction factor depends upon which? Okay, now hydrodynamically smooth boundaries, इसको देख रहे हो? Are you able to read the statement? For hydrodynamically smooth boundaries, so automatically are we not eliminating the friction, the roughness part? If you try, again, yes, simply they would have been for hydrodynamically the friction factor of turbulent flow, you can go with option D. You can go with option B. But if you try to visualize this question, they have directly stated that, okay, fine. They are saying that for smoother boundaries, so definitely do we need to eliminate the surface roughness? I'm just asking you. It depends upon the flow. Very good. Very good. Okay. So can we go with option C or a D? I need answers from everyone. I need answers from everyone, C or D. And this kind of questions is being, ये आपका PYQ है. So they are being constantly asking in the examination. तो उसमें during the examination you will be having this kind of confusion. So try to eliminate here only. क्या है? Friction factor. Remember one thing. देखो, what is Reynolds number? Reynolds number depends upon various parameters. The viscosity, है ना? Viscosity depends upon the velocity. It depends upon the we can say characteristic dimension, that is length or we can say diameter. Okay, yes, exactly, very good. Even though they have written smooth boundaries, but you have to take the roughness also into consideration. Remember, ये बहुत important है. Students do get confused कि smooth boundary. इसलिए I have just highlighted specifically. ठीक है? So it depends upon the Reynolds number. Definitely it depends upon the Reynolds number, but along with that, it depends upon the roughness. So we can go with option D, not with option C. It is not only dependent on Reynolds. अगर ये होता dependent on Reynolds number, that would have been correct answer. But only Reynolds number, that would not be completely correct. ठीक है? So we can go with option D. So we can go with this one. ठीक है? Right? Done. Perfect है. देखो, this kind of confusion need to be discussed. That is the reason इस type के जहां पर भी confusions questions होते हैं, we have already taken so that you are eliminating all the problems. Turbulent flow occurs. Okay, very easy question. This was question number 21. Okay. Turbulent flow generally occurs at which point? At very low viscosity, very low velocity, at very high viscous fluid, in a flow through a very narrow passage, in flows at high velocity through large passage. A, B, C or D. Turbulent flow, Reynolds number greater than 4000, flow through pipe, through pipes, right? And we know that Reynolds number is equal to velocity into the characteristic dimension by the viscosity, kinematic viscosity. Again D. Low velocity नहीं होगा, high viscous. देखो, try to remember, if mu is very high, R will be very low, नहीं हो सकता. Narrow passage में diameter is very less, नहीं हो सकता. Option D is the correct answer. Perfect. D we can block. 100% correct. 100% correct. Okay. Even though if you're having doubt, you can confirm from the formula also. Option D correct. Very good, Arnab. Very good, mechanical Bijoy, Negi. Next question, 22nd. Head loss in turbulent flow in a pipe varies directly as velocity, varies inversely at the square of velocity, varies approximately at the square of velocity, varies inversely as velocity. देखो, usually it is being expected in the month of we can say June, first week of June. जैसे ही आपका SSC JEE होता है उसके आसपास ही they are releasing the notification. We are expecting कि भाई आ जाए आपके जून में. ठीक है, चलिए 22nd क्वेश्चन. A, B, C और D. A, B, C और D. Varies directly at velocity, inversely as the square of velocity, varies inversely as velocity. अरे भाई, हेड लॉस ना, फॉर्मुलेशन क्या होता है? FL V² by 2 into G into D. So it is directly proportional to V². Square, option C. Not approximately. Darcy's Switchback equation, FL's V² by 2GD. अरे Bijoy, A is incorrect. Square of velocity. Okay, fine. Clear? You are able to revise, na? Mr. X, you are able to revise everything by using this formulation. Chaliye, question 23rd on the screen, very easy again from the dimensionless number. The ratio of inertia to the elastic force. The ratio of inertia to elastic force, this ratio is called, basically ये root भी होता है ना, it's basically root of this is called what? Weber, Reynolds, Mach. देखो, Reynolds नहीं हो सकता, Weber already we have seen. Mach and Froude में से you have to tell me. Inertia by elastic. Option A, B, C or D. A, B, C or D. Option C is the correct answer. Mach number. अच्छा, वेबर क्या होता है? हाँ, inertia to surface tension. Reynolds we know. Froude's number, I think previously one of the students have already told me. Very good. Option C, Mach number is the correct answer. ठीक है. 24th question on the screen. The component of the force of the fluid on the body which is generally inclined to the direction of motion of the body parallel to the direction of motion is called. हाँ, थोड़े से लेट हो रहा है. I'm able to see at least like 10 seconds या 10 नहीं 5 seconds का थोड़ा सा delay is there. So चलिए quickly, A, B, C और D. Drag, lift, wake और propel. Drag, lift, wake और propelling force. A, B, C और D. भाई सिंपल सा क्वेश्चन है. In the direction of motion, force का वो component in the direction of motion, what do we call that? Is it a drag or lift or wake or propelling? बताइए. If there is a force, this in the direction of motion, what do we call this force, this component of force? Drag, lift, wake or propel? Lift कैसे होगा भाई? Lift तो हो ही नहीं सकता. Lift is the first option that you can eliminate because lift will be perpendicular to the direction of motion. Option A, drag. Option A, drag is the correct answer. They are asking parallel to the direction of motion. That means in the direction of motion, what is the component of force called? That is definitely we can call it as drag. Now it's correct. Mr. X, A is the correct answer. Chaliye, 25th question on the screen. Cavitation is caused by, cavitation is caused by high velocity, high pressure, weak material, or low pressure. What is the phenomenon of cavitation to occur? What is the reason for cavitation to occur? You might have seen the surface is getting deteriorated, surface kharab ho jata hai, the surface becoming we can say small pits is being seen due to this cavitation, and definitely it is being observed due to the only one very important reason, that is very low pressure. Even I can write very also, low pressure ki jagah very low is the most appropriate answer. Okay, option D is a correct answer. Very good, done. Next question 26 on the screen. Okay, from fluid machineries, overall efficiency of the Pelton turbine is 70%. ठीक है, overall आपको दे रखा है, they have given the overall efficiency that is 0.7 and mechanical efficiency is given as 85, that is 0.85. What is the hydraulic efficiency? What is the hydraulic efficiency? Very easy question. We know that overall efficiency is equal to the product of mechanical into the hydraulic. यहाँ से निकल जाएगा 0.7, 0.85 hydraulic. So hydraulic is equal to how much? Yes, quickly, A, B, C or D? 0.8, 0.824 something. Please check. Option A, 0.824. Approximate, you have to do the approximation. You have to do the approximation, guys. Thoda sa you have to do, because these are very easy questions, and you have to solve without using the calculator. Okay. Very good. Option A is a correct answer. Yes, Bijoy, Negi, correct. Next question. Can we go with the next problem? Yes, 27. All good. Perfect. Next question, 27th question on the screen. Pseudoplastic substances are non-Newtonian fluids for which A, dynamic viscosity decreases with time, for which the shearing force is applied. Dynamic viscosity increases with time. Dynamic viscosity decreases as the rate of shear increases. Dynamic viscosity increases as the rate of shear increases. A, B, C or D? Simple question. You have to calculate. You have to do some approximation up to 2 decimals. Bijoy? Because in JEE examination, calculators are not allowed. You have to solve some basic approximation by using this. Okay? Yes, Bijoy, done. Our next 27th question on the screen. A, B, C or D? Quickly. हो जाएगा यार, हो जाएगा. You have to just practice. They're asking about pseudoplastic substance. We know that tau is equal to mu du by dy to the power n. And for pseudoplastic, what is the value of n? Yes. For pseudoplastic, the value of n is less than 1. If value of n is less than 1, that means if the dynamic viscosity decreases, the rate of shear stress will increase. It is inversely, or we can say it is proportional to like this. ऐसा होता है. This is your pseudoplastic, है ना? This is your Newtonian fluid. I think this is dilated, है ना? Dilated. Very good. Perfect. ठीक है. Option C is the correct answer. Clear है? Done. Very good. Perfect. ठीक है. This is like this curve. Newtonian definitely is a straight line. These are non-Newtonian. Pseudo and dilatant are non-Newtonian fluids. Chale, next question 28th on the screen. Mercury does not wet the glass surface. This property of the mercury is due to. Why this property of the mercury that it is not wetting the glass surface? What is the reason for this? Adhesion, cohesion, surface tension or viscosity? Adhesion, cohesion, surface tension or viscosity? A, B, C or D? if you're having a flat surface, okay, and if you're keeping a mercury, obviously, because of the higher force due to within its own molecules, cohesive force की वजह से, cohesion we can say within its own body, right? That is cohesion. तो cohesion की वजह से it is not actually wetting the glass surface. It is having more force than that of adhesion. और इसकी वजह से the mercury is not wetting the glass surface. Next, 29th question on the screen. 29th है? हाँ. Which is the law that states that the intensity of the pressure at a point in a fluid at rest is same in, अरे भाई, very easy question. The second easiest question of today's session, and that is also second last problem. Bernoulli, Newton's, Pascal और Darcy's, A, B, C और D. सिंपल है भाई, एक पॉइंट पे हर एक डायरेक्शन में द फोर्स एट अ सेम लेवल, दैट इज नथिंग बट पास्कल्स लॉ. Okay, option C. Very good, perfect. Last question, 30th question on the screen. Which type of force dominates a fluid flow with very high Reynolds number, that is approximately 10,000? Reynolds number is very high. Which force is dominating? Inertia, viscous, reaction or divergent? देखो C और D तो नहीं हो सकता. You have to go with either A or B. Either A or B. We know that what is Reynolds number? It's a ratio of inertia force to the viscous force. है ना? Inertia force to the viscous force. Reynolds number is very high. इसका मतलब inertia force is very high. Option A. Option A. Obviously. है ना? Option A is a correct answer. Perfect. So these are the top 30 most repeated PYQs that we have discussed in today's session. Tomorrow at 7 p.m. we'll be talking about the second most highest weighted subject for mechanical student, that is thermal and application. Application में it includes power plant, RAC, IC, सब कुछ. ठीक है, it includes all the three parameters. Tomorrow at 7 p.m. All good? ठीक है, 30 questions again, same pattern. We'll be trying to cover and we'll be able to solve each and every question in this by discussing each and every question. Okay, ठीक है, fine. So एक गलत हुआ, कोई दिक्कत नहीं है. So still a very good score. Technical में you have to have at least more than 85% should be your score in technical. Then only you will be able to get an advantage over non-technical portion. क्योंकि देखो as a mechanical students, as a engineering graduates, हमारा जो सबसे weakest point होता है that is a non-technical part, right? और non-technical part weak है तो हमें technical को strong करना पड़ेगा. Definitely, no worries. We'll be discussing day after tomorrow. We'll be having mechanics also. Clear? So mechanics also we'll be discussing. No need to worry. So for more such awesome videos, do subscribe to this channel because we want you guys to excel in the different examination. For that, you have to subscribe and enjoy this free sessions for your exam preparation. Okay, thank you guys. Bye bye. Do take care of yourself. Before leaving the session, please do like the session and share this video to all of your friends. Okay, thank you. Bye bye. Take care and stay safe. Bye bye.